I would be going up with some mathematical foundations. So I would be discussing about sets, what they are, and then what kind of sets we can have. And then I would move towards functions. And then we would be shifting towards graphs. And then I would be talking about languages. So if you talk about language, so you can't say this is somehow English language or Urdu language. So I would be telling you what exactly do you mean by language. And then I would be somehow mentioning about theorems, what is somehow theorem for you guys, and then how could you prove those theorems? So if you have some sort of theorem, so how could you prove that? So, and then if time allows me, I will be moving towards the main course of this class. That is to start with theory of automata. And when I would be starting up with theory of automata, so I would be discussing first deterministic finite automata. That is commonly known as DFA. So if you guys have taken the class theory of automata and formal languages in your bachelor's, maybe, then you guys would be familiar with DFA, what exactly it means, okay? So this is what I intended to cover in today's lecture, but again, it depends if time would be allowing us, and then I would be discussing everything that I showed you in this slide. If you want to go through more details of whatever I would be, teaching you in today's class, so you can visit section 0.2, and then you can go through section 1.1 as well. So this 1.1 belongs to deterministic finite automata of the book. So book is quite important. So it is Introduction to Theory of Computation by Michael Sipser. So this would remain the main book that I would be following. But again, when I would be switching to the other book, so I would be mentioning explicitly over there that I'm taking these sections from that book. Okay, so starting up with sets, guys, so this is somehow a collection of, any objects. So those objects can be, numbers, those objects can be anything else as well, okay? So the most commonly used sets are set of natural numbers, integers. If you talk about natural numbers, so we often use it in our daily life, that is 1, 2, 3, 4, up to so on and so forth. And if you talk about integers, so they would be including the negative numbers as well. So they are somehow negative numbers that would be included here. And if there isn't any sort of object in some set, so that set is known as empty set. And then we have some operations on these sets. One of them is union, the other one is intersection. So union means that you are combining the data from both of these sets. And intersection means that you have to check if some objects are present in A and then again they're present in B as well. So the objects which are present in both these sets, so that would be a part of intersection of A. And then we have complement of A. So this means that whatever that is present, that is not present in A, that would be a part of complement of A. And then it comes the very important thing that is known as cross product. And this would be used in course theory of automata. So you should be, familiar with this as well. So if you have two sets A and B, so you can call its cross product as A cross B. So how could you evaluate that A cross B? So for example, if you have two sets of natural numbers, one is n, the other one is n, so the n cross n set would be having pairs I, j, where I and j can go from 1 up to so on and so forth. Okay, so I can give you a simple example over here. So for example, I have a n1 over here that contains maybe 1 and 2. Now this is my set of natural numbers, only containing two objects over here. That is 1 and then 2. And I want to take a cross product of both, the cross product of n1 with itself. Okay. Now this means that I have to make pairs. So for example, I can take one more n1 over here. So this is the second instance of n1. Now this is my 1, this is my 2. And I would make pairs by picking one element from here, this n1, and one element from here, this n1. So that makes it as 1, 1. This is one pair. 1, 2. Yes, so the other one would be 1, 2. 2, 1, 2. And then it would be 2, 1, and 2, 2. So you said it rightly. So this would be 1, 2. And then you would be having 2, 1. And finally you have 2, 2. So this means that you are picking elements from both of these sets and you are making somehow the pairs out of these. And that kind of set is known as cross product of the given sets. They can be the same sets, as I told you over here, that can be n cross n, or they can be different sets as well. So there isn't any sort of difference between both. So you have to pick one element from here and then make pair with each element of the other set. And then you take the second element and then make pairs. So this is how you can find out the cross product of two given sets. And then again, if you talk about that A, comma B, so that would be known as tuple. So tuple is somehow, if you make some sort of, combinations of different objects. So for example, this tuple, which is 4B, this is commonly known as pair. We have 4 and then we have B. You can have 3 tuple, you can have 4 tuple as well. And then you can have K tuple as well. So K tuple means that you have K elements within that, that small brackets that you could have. If you more talk about sets, so we have power set. So this is a quite important thing that you need to take off, okay? So this power set is the set of all subsets of the given set. So for example, if you are given with a set A, which is 0, 1, okay? And then you have to calculate power set of this set A. That is known as P of A. And first you have to calculate all those subsets of this set A. And if you enclose that, those are all subsets into different set, that is somehow known as, power set. So in this case, it would be, empty set, then 0 alone, then 1 alone, and then 0, 1 both combined in this case. So only 4 elements would be a part of the power set for this set A that is given in our example. Now these sets can be represented in graphical forms as well. So for example, if I have two sets A and B, so they are somehow denoted with these circles over here. They are represented with these circles. And A union B means I'm combining A and B. So I'm combining elements of both A and B. That would be a set something like this. So this would be my A and B. This is my A union B. This is, I'm combining both A's and B's. As far as A intersection B is concerned, so I have to take all those elements that are common in both A and B. So that would be something like this. This is somehow A intersection B. This is the only part that is shared between A and B. And that is known as intersection of A and B. I mean, these are simple concepts. So you can represent these sets in the form of, Venn diagrams as